So this is basically sort of a continuation of what we have seen up to now. So I hope that you enjoyed to feeling at least the eclipse. Unfortunately, we couldn't see it, but we could certainly feel the drastic and very sudden decrease in temperature. The temperature went down probably between 5 and 7 degrees all of a sudden. And you could really feel the difference and the wind. The wind that you felt is called the eclipse wind, which is a weird one. It doesn't feel natural, and it is not a natural one. So you could feel it. Unfortunately, it didn't become so dark or as dark as it should have because it was cloudy, and so the clouds, unfortunately, scattered a bit too much light. Okay, so even though they didn't allow us to see the sun, but they were sort of unpleasant enough to scatter the light from the sun, and that's why it didn't become as dark as it should have. But anyway, so in this lecture, the idea is to talk about the physics of the eclipses. So we talked already about the physics of the eclipses during the event earlier, but here I can show you some images to make the point, and then we will look into the history of eclipses. So first of all, we have okay, so we will look at what is an eclipse, we will explain the eclipses, and then we will look at the history, in particular in Babylonia, Egypt, China, and also all the New Testament. I mean, even in Christianity, and in the Bible, which is the holy book of Christians and Catholics, there are a lot of sort of hints of eclipses, and I will show you some of them. So, what is an eclipse? Well, we have already discussed that this morning, but basically, here I put some pictures that can make they can clarify what an eclipse is all about. So, as we have already said this morning, we have an eclipse when one heavenly body moves into the shadow of another heavenly body. So, what does this mean? Well, I put here the two pictures of a solar eclipse and a lunar eclipse. So what we experienced this morning, it was a solar one. So what happened was that we were on Earth, and the moon slowly, from west to east, came into the basically the line of the sun. So the sun was shining light, well, it is shining light, even though we can't see it, that's what it keeps doing. But then the moon slowly came in between. So there was a perfect alignment between Earth, ourselves, the moon, and the sun. And that's what basically happened. Now, as you can see here, the moon is basically projecting a shadow on Earth. And this is the shadow in which we were. Now, because we had a partial one here in London, we were not in the umbra, as I was saying earlier, but in the penumbra, and I will show you what it is. Now, in terms of the lunar one, is basically the other way around. So, in the sense that what is between the sun and the moon is ourselves, Earth. So, remember that the moon is orbiting around us, okay? So, in one case, the moon is between the sun and ourselves, solar eclipse, but when the moon is on the other side of the Earth, and this happens during its orbiting, then we have lunar eclipses. Now, solar and lunar eclipses, they keep happening during the year. We talked about the 346 days of an eclipse year, which means that about every now and again, quite often, to be honest, these eclipses happen. We can't see them in the same spot, but basically you can keep roaming around Earth and keep watching them, which is some people do that, in particular astronomers. So now, let us now talk about umbra and penumbra. Here we were in the penumbra. But because we had 85%, we were basically at the edge of the penumbra, very much towards the umbra. Now, as I said earlier, umbra comes from Latin and means shadow. Okay, sorry. Right, just quit. So what we have here, and I will show you the pictures. So in the umbra, the disk of the sun is completely blocked by the moon. So which means that the moon, the sun, and the earth are aligned in a perfect way, just on one line. In the penumbra, it's just partially blocked. So that's what we see. Here, that's what we were. We were somewhere here in this penumbra. Okay? So here is more clear. This is the umbra, okay? And this is the penumbra. So this is the earth. Now, as you can see, the umbra is very dark. So if you are on earth and in a point on earth where basically you are inside the umbra, then you will get a total eclipse. If you are somewhere in the penumbra, you will get a partial one. We were somewhere in the penumbra, but we were quite close to the umbra anyway. That's why we got 85% of eclipse. So now, as you can see, the penumbra is much larger than the umbra, so it's much easier to see a partial eclipse rather than a total eclipse. To see a total eclipse is quite a rare event. It can probably happen a couple of times in a human being life, not more than that. Penumbra is much more to see a partial one is more common. So now let's talk about the solar eclipse, because that's what we saw this morning. That's what we experienced this morning. So we have said that the moon blocks the light of the sun from reaching Earth. That's what happened, and that's why it becomes darker. So now this obviously causes the eclipse of the sun. Okay? So that's the image I was talking about earlier. So that's what happened in 1999, for example. So this shadow is the shadow of the moon. And this was part of Earth. So all the people who were in this shadow saw the total eclipse. Okay? The people who were like more at the edges of the shadow, probably they saw a partial eclipse. So, and this one is part of a movie. So is if you go, I think, on the NASA website, then you can see it. See the movie from where this picture was taken. Okay, as we were saying, the solar eclipses, they happen only during new moon, not during full moon, and this is because of the position of the moon. When it is new moon, the moon is between the sun and ourselves. When it is a full moon, it is on the other side of the Earth. So that's the reason why we have the solar eclipses occur only during a new moon. So now we were talking earlier about the moon's umbra. So the moon's umbra is not very large, it's just 380,000 kilometers long, which is not much at all. And here we go. So this is the umbra. As you can see, it's a very, very tiny spot, and that is where basically people from Aberdeen upward they were. We were here at the edge in the penumbra. Okay. So the moon's umbra is therefore quite small. So basically, it's just large enough to touch the Earth and allow a total eclipse to happen in a very particular and precise spot on the Earth's surface. Now, there are three types of solar eclipses, as we have already said. So the first type, which is what, as I said, people in the north certainly saw, is a total eclipse. That's what you saw in the live streaming when we came back from outside, and you could see the total one. So as you can see, you can basically you have the moon covering completely the sun, and this type of eclipse is quite good also to study some characteristics of the sun itself. Okay, then we have the partial. That's what we saw here in London, or we saw through streaming. So in the partial one, as you can see, and that's what you have experienced, basically the sun is not completely covered by the moon, only partially. And then we have the annular one. This is the annular one, where basically the moon is covering the sun, but obviously not completely. So it's quite good, as my colleague Ali was saying, to study the corona of the sun, called also crown of the sun. So these are the basically three types of eclipses. Now, in the annular one, as you can see here, the moon seems to be quite smaller than the sun. And this is because, well, that's what it is after all. The moon is not certainly larger than the sun. So this is probably the one that reflects better the sizes of the two heavenly bodies. Now, we were talking, before going outside earlier today, we were talking about the Saros cycle, which is a cycle that, as I was saying, it covers 5,000 years, from 2000 BCE up to 3000 CE. So we are almost at the end of the Saros cycle. So the Saros cycle helps to understand when the eclipses will happen. So the solar eclipses, they happen every 18 months. So they happen once every 18 months. They last for a few minutes. As we were saying, they last between 7.5 and 12.5 minutes. And so the reason why we study them, the reason why we bother to study solar eclipses is because, as I said earlier, we can study the sun's corona. So here, this is from the 1999 eclipse. So as you can see, this was the total one, obviously, and here we can see all the ejection basically from the sun. So it's possible really to study the corona of the sun. So solar eclipses are very nice tools that basically the astronomers and astrophysicists use, and also whoever really is interested in the sun, they use as a tool to study some characteristics, some sort of physical properties of the sun. So the sun's corona, as you can see here, is something quite extended, and basically it extends for millions of kilometers from the sun itself. But the problem is that if the sun is not covered, it's very difficult to see it. Now the Saros cycle. The Saros cycle, which I said lasts for 5,000 years, this cycle arises from basically a sort of periodic type of pattern between three of the moon's orbital cycles. So the three cycles are the following. We have the synodic months, which goes from new moon to new moon. So it lasts for about 30 days, 29.5. And this one, if we want to see a sort of picture, that's what happens. So this is the moon's orbit. The moon's orbit is an elliptical one. We have the perigee and the apogee. So the perigee is a point at which the moon is closest to the Earth. The apogee is the greatest distance. And this is obviously the major axis of the ellipse. So the moon keeps rotating around. So now, the next month, which is used in order to to use the Saros cycle is the anomalistic months. The anomalistic months goes to perigee, from perigee to perigee, and it lasts for about 27 days, so it's slightly shorter. So this is the anomalistic months. It goes from perigee to perigee. Okay? So the perigee is the closest point at which the moon can be compared to Earth, with respect to Earth. Okay? So it goes from here, then the moon comes back, and it comes back to the perigee. So this is the second type of months that we can have, lunar months. Then, now the anomalistic months can also consider the apogee to apogee. So the apogee is the farthest, the greatest distance of the moon of the moon from the Earth, and again the moon can go from an apogee to the next one, again to go back to the apogee, and this is again is an anomalistic month. So basically the Saros cycle is using this movement of the moon to understand and to calculate very precisely when all the eclipses, both solar and lunar, will happen. Because as I said, the solar eclipses follow a very strict and regular pattern, because nature is ordered. Finally, we have the draconic months. It goes from node to node. Okay, let us have a look at it. Again, it lasts for about 27 days. Now, here we have again the cycle of the moon. So here we have the perigee, we have the apogee, and here we have the nodes. So this is the new moon. The new moon, as you can see, you have a new moon when the moon is basically directed towards the sun, and this is the Earth. We have full moon when the Earth is on the other side of the Earth. That's why we have solar eclipses only when we have a new moon, because the moon is on the right side of the Earth, so it's basically between the Earth and the sun. For full moon, it is on the other side, so it is the Earth which is between the moon and the sun. That's why we have the lunar eclipses. Now, here we have two nodes, ascending node and descending nodes. Okay? So, therefore, the draconic period calculates, basically, going from one node to the other. Okay, so the two nodes basically are the quarter of the moon. Sometimes you say it is either full moon or half moon or a quarter moon. That is when you see the quarter moon. So you know that it is at one of the nodes. So this is the third type of lunar months. Okay. So this is another sort of image that was probably more clear. So here you go, the Earth is here, this is the moon, and it goes from there to there. So again, descending and ascending nodes. So now, now that we have seen a bit of the physics behind, and that's what we talked also earlier, but at least now we could see some images just to clarify a bit the concept. Let us see the history of eclipses, in particular solar eclipses. I didn't put the lunar ones here. I can probably mention them, but the examples here are the solar ones. So usually the solar eclipses were viewed as bad signs. So they were bearers of either bad news or disasters, etc. Death, destruction, and so on and so forth. Okay? So ancient civilization, they really tried very hard to understand them and to predict them. So even though in the past, and still nowadays, in some civilization here still on Earth, some people are quite frightened, by eclipses, in particular solar eclipses. Then we have that people, particularly Babylonians, Egyptians, they were trying to understand them and to predict them. So they were not frightened from them, they just tried to understand them. So Babylonians, and in particular ancient Chinese, they could predict solar eclipses as early as 2500 BC. So very, 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 very early. So now, in particular, still now, solar eclipses were seen, particularly from Vietnamese people, think that the total solar eclipse happens because a sort of dragon is eating up the sun. And in fact, we will see that later when we'll talk about the Chinese one. Going back to the Babylonian one, so the first eclipse that was recorded in clay tablets that were found in Babylon, well, they basically recorded an eclipse that happened on May 3rd of 1375 BCE. This is the earliest one that was recorded. So, okay. Now, Babylonians were extremely accurate in predicting eclipses. They were very, very good at it. And in fact, it's because of this knowledge that is, in particular, biblical scholars try to basically understand when some of the events in the Bibles were happening. So, from here, the Saros cycle, so which is a lunar cycle, comes. Okay? So, the Saros cycle predicts a solar eclipse every about 18 years. And in fact, the next solar eclipse that we will have here in the UK is in 2026, which is not going to be, I believe, a total one. So, there is an eclipse quotation in one of the tablets that they were found in Babylon. So it refers to the solar eclipse that happened on 27th of May, 669 BC, and it says, if the sun at its rising is like a crescent and wears a crown like the moon, the king will capture his enemy's land. Evil will leave the land, and the land will experience good. So this one was found, basically, it was written by Resil the Older, and he was a Babylonian scribe to the king. So the eclipses were basically used also to see if the king was going to be, for example, successful in his war, or if there was any problem with his kingdom, and so on and so forth. Now, in ancient Egypt, the Egyptian also, they were very much, they were pretty good at predicting the solar eclipses. The problem is we do not have any direct evidence of that, or we couldn't find it so far. But we had plenty of evidence from other people. For example, we have an evidence from Plutarch. He was a Greek man who lived between 45 AD and 120 AD. And through him, we can know that ancient Egyptians were explaining solar eclipses by the passage of the moon between the sun and the earth in daylight hours, which is exactly what happens when you have a solar eclipse. So again, Egyptians we suppose that they were using solar eclipses again, I think mainly to then understand really the movement of the heavenly bodies, rather than trying to see if one pharaoh, for example, was more successful than another one. In ancient Greece, the most famous astronomer is Ptolemy, and he basically developed an extremely sophisticated scheme to predict both lunar and solar eclipses. And these schemes are still valid, and if you use them, you can still basically predict quite nicely lunar and solar eclipses. So one thing that Ptolemy did, for example, was that he knew the details of the orbit of the moon, including the nodal points. So it was extremely precise in describing that. Okay. So the problem is that even if Ptolemy was good at, the sort of knowledge he had was not enough to predict very, very precisely the solar eclipses. Okay? So, in ancient China, the solar eclipses were associated with the health and the success of the emperor. Now, here, the fact of not predicting one meant putting the emperor in danger. So, for this reason, there is a sort of story of two astronomers, He and Ho, who couldn't predict one eclipse because they were too drunk to do that. So, because they didn't do that, because they didn't predict it, they were put to death. And that sort of taught a lesson to everybody in China that solar eclipses and lunar eclipses must be predicted, because if the emperor couldn't know what was going to happen, this was obviously not a very good thing for the emperor himself and for his success in life and during his reign. So, as I said, the solar eclipses were seen as a legendary celestial dragon which was devouring the sun, and in fact the term used for eclipse was shi, which means to eat in Chinese. So that's basically what the Chinese were thinking and were the way they were seeing eclipses. Now, again, in ancient China, the ancient eclipse records, they used to measure the rate of Earth's spin about its axis over the past millennia. So, the observation the Chinese did of some eclipses, at least 5 solar eclipses, they were used to study the rate of Earth's axial rotation over the past 3,200 years. So, I mean, they were really using it not just to try to understand if the emperor was going to be successful during his reign, but also to do something more scientific. So, one thing that they, for example, that people nowadays discovered by looking back at the Chinese records of the eclipses is that the day in 1200 BCE was 0.047 seconds shorter than the present day. So, I mean, it was a nice way really to understand the rotation of the Earth during the millennia. Now, let's talk about the Old Testament. As I said, there are a lot of sort of places in the Bible, both mainly the Old rather than the New, where the eclipses are mentioned very, very clearly. One example is this one, is in Genesis 15:12. So it's written that, now when the sun was going down, a deep sleep fell upon Abraham, and behold, terror and great darkness fell upon him. So now, this one, obviously, you can see it from a religious point of view as, God sort of talking to Abraham. But you can also see it from a more scientific point of view as a nice description of a solar eclipse. And in fact, there is a possible relation between this passage and a solar eclipse that really happened in May 9th, 1533 BCE, which was the period where Abraham could possibly have lived. So that's how even the Bible can be a nice point of reference to see when eclipses were happening. Another one is in Amos 8:9. It will come about in that day, declares the Lord God, that I will make the sun go down at noon and make the earth dark in broad daylight. So again, this is sort of nice description of a solar eclipse, and there is a possible relation to a solar eclipse that was occurring in 763 BCE. Then we have also Joel. Darkness comes upon them in the daytime. At noon they grope as in the night. Okay? And then we have another one. The stars of heaven and their constellation will not show their light. The rising sun will be darkened and the moon will not give its light. So these are just descriptions. We can keep going, and obviously I will not. Description of solar eclipses. So this means that at the time they were quite good at understanding how the solar eclipses were happening and why they were happening. So that the moon was basically between the earth and the sun. So now there are some eclipses which are mentioned also in the New Testament. Most of them are more lunar than solar. For example, in Matthew 24:29, immediately after the distress of those days, the sun will be darkened and the moon will not give its light. So again, the same description. The stars will fall from the sky and the heavenly bodies will be shaken. So basically, this is almost the only description, that we have of the solar one. We have another description, very nice description of an eclipse, but it's a more a lunar one, and it is during, Jesus' crucifixion, when darkness came, etc., etc. Now, the description seems the description of a solar one, but scientifically, it couldn't have happened, a solar one, only a lunar one. So the debate is, even between scientists, that what it is described there, it is an eclipse, but it cannot possibly be a solar one, even though the description is the description of a solar eclipse. So this is just to give you an idea of what, of how people basically have seen and have experienced eclipses during the year and during the millennia. And this is probably the way also many people nowadays sort of feel them or feel about it. So that's what I wanted to tell you about eclipses, the physics behind, so what happens, and also the history of them. Okay, so do you have any sort of question or something you want to ask about? Yeah.
What kind of effects does a lunar eclipse have on the Earth?
On the Earth? Well, lunar eclipses on the Earth, from a more natural point of view, maybe after all not much, in the sense that the moon is related to the tides, etc. So you could probably have some changes in the tide, the way you have ebb and tide, but not the change. Sort of, you will not feel what you feel when you have a solar one. Okay, so you can see it. You can see that something is happening because the moon is becoming red, etc. But you will not probably have the same impact on the magnetic field of Earth, etc., that you have when you have a solar one, which is, from a natural point of view, has a sort of larger impact. So, any other question you may have? Any curiosity, even from the historical point of view or something? Yes, of course that you can.
You've referenced the Bible. Are
Yep.
there any mentions in other holy books, like the Quran or?
I'm not aware of. Probably there are. I don't know, Ali. There are any in the Quran? Any? There are.
A few mentions of ones in the 3rd and 4th BC.
And they were describing them. Yeah.
I think there's at least one in the Torah as well.
I think so, because it's part of the Old Testament. Yeah, like the Genesis is part of the Torah, and so that is already one of those. Yes, it's because solar and lunar eclipses were really related to the life of those people, and the holy books were sort of describing their lives, literally. Like the Torah is really describing how Israelites were living at the time. So they were really recording what was happening, and for them a solar eclipse was a sign from God, because obviously it was something totally different happening, and so they were thinking that God was talking to them somehow. So any other question you may have? Yes? Oh, sorry, then I will come to you. Yeah?
Why is the solar cycle going to end in the future?
Well, the problem of the solar cycle, I mean, that's a very good point. The solar cycle as it is at the moment is 5,000 years. But obviously, nobody is stopping people from keep, recording the movement of the moon and keep sort of counting or trying to predict when solar and lunar eclipse will happen. Now, the solar cycle was started very, very long ago. So the people who created the solar cycle, and we're talking about people, back in 2000 BCE, they just stopped at 3000 CE. But obviously, people now can keep going on and sort of making the solar cycle, longer. This is the solar cycle as it is originally. Yeah.
I believe in the Bible myself, but from what I understand, historians think about that particular verse, Matthew 24:29, that's one of the Bible's prophecies about the future, which would explain why that's describing the wrong eclipse, I think is what you said.
Yeah, I mean, is more than this one is the one when Jesus was crucified, then there was darkness. So that one, even though if you read it, the sun is dark, it's not certainly night, so it looks like a solar eclipse. But this is the controversy, because if you read it, it's the description of a solar eclipse. But then, from a scientific point of view, it couldn't have happened possibly, because it was not the right alignment. So people think it's a lunar one, but the description is not of a lunar one. So, that is the debate. We're still going on. Who is right? The person who wrote it, or the person, or the scientists who are saying, no, it can't be a solar one. So there were also debate on the date then. Some people say, well, the crucifixion then happened 7th of April, because that is the day where sort of that type of alignment could happen. Some people know, well, no, it's better another day, another period, in 33, BC, CE, because that one is more possible. So still, they can't make up their mind. But yeah, this one could be the future. It could be definitely this one, because more of the prophecy are for the future, like the Isaiah ones are for the future. So it could possibly, yeah, absolutely. That's why it's difficult to pinpoint them, because you can say, well, it happened when the person wrote it, or the person is seeing the future, and that is the debate.
Because it doesn't match with the history.
Yes, yes, absolutely. Yes?
We know that the moon is receding away from us. Does that play any role in the way we will observe lunar and solar eclipse in the future?
Well, it could, in the sense that obviously if the period that the moon takes to orbit around us changes somehow, then obviously also the calculation will change. So then you have really to check if the orbiting of the moon is the same. That's why the solar cycle lasts for 5,000 years, because more or less the moon is orbiting more or less in the same way. But then you have to take into account any possible change in the orbiting of the moon in order to be sure that you are sort of predicting the right eclipse at the right moment, at the right time, etc., etc. Yeah, you have to take that into account.
We know precisely the rate at which the moon is receding away from Earth.
If we know precisely that, I don't think so. Do we? I strongly doubt. Not precisely.
Once you think about the motion of more than two bodies moving gravitationally, it's not a problem that you can actually solve. You can use a computer to make a simulation. And then you add more bodies and it becomes more complicated. If you want to do that for the moon in the solar system, you have to include every body in the solar system. So all of the planets and the sun. It's quite complicated. So they have a rough guess. They believe that the period of the moon is going to shift slightly as the orbit of the moon is going to shift slightly. It's called precession.
Yep.
But they're not really sure.
Yeah.
They won't really know. They can get a better. We can say what the moon's going to be doing tomorrow. But if you ask what the moon's going to be doing in 50,000 years, that's a little bit of a more complicated question. We roughly know the motion, but how much it will move is a.
It's another matter. Yeah, it is. I mean, it's not as easy as it can seem. So, any other question you may have? Yeah.
What did Britain believe that the solar eclipse done? Obviously, like in the ancient.
Sorry, say it again.
What did Britain believe about the solar eclipse? Sort of in
So all Britain, or I believe so. I strongly believe so. And if you think about Stonehenge, they did believe in that. I mean, Stonehenge is well. What is Stonehenge is a great debate. Also, that one is it an astronomical observatory or it is a sort of temple? Nobody knows. But one thing is sure, that the way the stones are disposed is so precise that the same thing as the equinox and the solstice, they happen, and still they happen the same way since thousands of years. So they certainly believed in eclipses, and if then they were scared of, this is another matter. There are not many records about that. So this is a bit, again, a debate. But certainly they will believe into it. That's why they try to, pin down what was happening with the sun, with the moon, etc. But it's not certain if they were frightened by, because there are not really records. But at that time they were certainly probably frightened a bit, because probably they couldn't understand it completely. But certainly they were also intrigued by it, I would say. Yeah. I mean, we are talking about, quite a Roman period also, and they were quite frightened by it. Yeah, absolutely. Any other question you may have? Any curiosity or anything? Yes?
You said that animals go a bit wild.
Yes, they do. They do.
During the eclipse.
Yeah.
How do they know, do we know why they know that the eclipse is coming, or
yeah.
do they just sense it like dogs?
They sense it. They sense it because, for example, some birds, they don't know where to go anymore. So yeah, even earlier I saw a bird that all of a sudden he didn't know where to go. It was literally flying peacefully, and then all of a sudden it's like stopped, and he didn't know where to go. Because and it was a moment when we started feeling the eclipse wind, and it became cold like anything. Because there is, as Ali also was saying earlier, there is a change in the magnetic field, and because the birds are using the magnetic field in order to orient themselves, if there is a change, they are completely confused. It's like, for example, you're flying and your radar all of a sudden goes blank. And you say, oh my God, where I am. So it's the same thing. And that's why they stop singing, or they just stop doing whatever they're doing, because they're lost completely. And they start only when the eclipse ends, because again, the magnetic field becomes normal and they know what to do and where they are. Yeah. Any more questions you may have? Any more curiosities of any kind? Anything at all? Yeah.
Does the moon's colour change when it comes in front? Because there's another verse in
Yeah.
the Bible,
Yeah.
Acts 2, verse 20.
Yeah, what
where
does it
says that
say?
The moon, the sun will be turned into darkness, and the moon into blood. So the colour.
Yeah, that is a more a lunar one then, because the blood moon is a lunar eclipse. So that is a very nice. This is in Acts, which one?
Acts chapter 2, verse 20.
Oh, beautiful. I want to look it up. Yeah, this is a beautiful description of a lunar one. Because, as I was saying, during the lunar eclipse, the moon is behind the Earth. So we are in between the Earth and the sun. And because still there is some light scattered, so that's why it becomes red. That's the reason why in the morning the sun is red, and in the evening is red, and everything becomes reddish because of the scattering of light. So this is a beautiful description of a lunar one. Yeah, because this is quite sort of supermoon also when it becomes blood color. And to be honest, the blood moon was always seen as one of the most dangerous signs of either destruction happening, war starting, God being very angry with people, and so on and so forth. But in reality, just a lunar one. Yeah, a very nice one. Thank you. Any other curiosity? Well, in that case, thank you so much for joining us today. I really appreciate that, and I hope that despite the bad weather, you could enjoy at least the feeling of the eclipse, at least that. But thank you so much. So, and hopefully we will see you some other time, and maybe the next solar eclipse, or not lunar, but certainly probably solar eclipse. But thank you so much for coming. Thank you.